Hello, my name is Rodrigo Avila, and I'm going to be presenting Group 25's carbon sequestration project. Some background for this is carbon sequestration is the process in which we remove excess amount of carbon from the atmosphere that we can then later store. We know that all around the world there's been global temperature rises, and part of that is definitely because of the excess carbon in our atmosphere. The excess amount of carbon traps the heat around the globe, causing global warming and temperature rises. And if this trend continues, we can definitely see more consequences such as the rising sea levels, disturbance in agriculture, and more prevalent and powerful storms all over the globe. Engineers are needed for this because we need to learn how to develop new ways to efficiently remove more carbon from the atmosphere and more efficient ways to store it. Because if you can't do one of those two things efficiently, then it kind of negates the other. And that's why we created this code. This code really opens the eyes to people, engineers, and just anyone that really has a passion to solve this issue. Because this code uses dates in the United States and years between 1990 and 2011, and it gives them numbers and visual representations of just how much carbon is released into the atmosphere, broken down by industries within the United States. And that's why we picked it, because we believe as potential future engineers that this is one of the most prevalent issues globally. This issue will then later affect our kids, their kids, and just everyone around the world. Okay, so now moving on, I'm gonna go ahead and break down the algorithm in our code for you. So you start off by asking the user to enter a state within the United States, and we made sure to make this not case sensitive. So if you were to put a capital letter in front of Texas or lowercase letter, it should not matter. The code will still recognize that as Texas. But if it's not any of the 50 states within the United States, it will ask you repeatedly to enter a correct state. And then once you get past that, it will then ask you, would you want to enter a year between 1990 and 2011? If the year is within the range, then it will display a pie chart of all the emissions from every industry within that state and year. And if you say no, it will give you 3 chances to enter a year within 1990 and 2011. And if you can't do it within those 3 attempts, it will choose you depending which one you were closest to. After that, after the pie chart gets displayed, it will ask you if you would want to see more information, because the pie chart is just more of a visual representation of how the size ranges between the industries. So I'll ask you if you want to break it down further. If you answer no, it'll ask you whether you want to do it again or not, see another pie chart from a different state or a different year. If you answer yes, it will then tell you to choose an industry from the carbon emission you will want to analyze further. And we already know that you decided you wanted to see more information. So if you accidentally click out of the menu, it's just going to keep asking because, accidents happen. So then once you decide on which industry you want to see, an output statement with the values from that trial will display, and it will also tell you the per person energy usage. And then after that, a line graph will display and show you the future predictions of energy usage from that state. And so it'll show you a prediction through 2017 on what the energy usage might be. So then it'll later ask you if you would like to do another trial. So you could then again choose another state or another year, and it'll go through the same process. If not, the code will stop and it will display a table showing all the trials listed nicely. And it'll also display a statement of minimum and maximum values from any industry you chose. So it'll give you which industry displayed the maximum, which one displayed the minimum amount of carbon into the atmosphere. And then when the code's done, it will also export a trial table in Excel form. So for this part of the code, I'm going to allow my friend to run through the code, and I'm going to allow him to pick one state and one year, because I just want to show you how the code looks when that happens. And I'm going to allow him to introduce himself.
Hello, my name is Matthew Castillo. I am a petroleum inspector for a company called SGS.
All right, thank you for that. So I'm going to go ahead and run the section for you. And go ahead and enter any state you would like to analyze.
I'm going to put Texas.
Enter any year between 1990 and 2011.
Let's try 2001.
Okay, cool. So what pops up right here is a pie chart from carbon emissions by industry in Texas, and it splits it up by energy, industrial processes, agriculture, waste, electrical power, commercial, residential, industrial, and transportation. So that just gives you a good visual representation of how it's split up and the size ranges between all these. And now I'm gonna just ask you, would you like to see more information?
Yes.
All right, cool. So choose any of those industries and to evaluate.
Let's do energy.
Okay, so what pops up now is a line graph of the energy projection in Texas up until 2017. That's a future prediction of the code.
Cool.
So I'm gonna just go ahead and say no to the next trial because I just wanted him to run through one state. So I'm just say thank you for that. Now that my friend just finished the first scenario, I'm gonna go ahead and run the second scenario. So that's if you decide to pick more than one state and more than 1 year. So I'm gonna run the section. And I'm gonna go ahead and use something like Iowa, and I'm not gonna do capital letter just to show you that it's not case sensitive. So Iowa still ran, and I'm gonna go ahead and do 2012 just to show you that it's not gonna work. And I'll go ahead and do it 3 times, and boom, it automatically is gonna choose 2011 since that's the closest value after my 3rd attempt. So now you can see the pie chart displayed, same as in Texas. And I'm gonna go with yes, more information. And I'm gonna go ahead and just choose waste. And again, the line showing a projection up until 2017 of what the energy usage might be for Iowa. So now I'm gonna be all like, yes, I do want to add another one. So he's gonna ask me for another state. So I'll just go ahead and put America, which we both know that that's not a state. And it's not going to let you, so that was a good thing. So now I'm going to go with Ohio. And I'm going to choose a year of 1997 since I was born then. And again, once again, you get the same pie chart as the other ones. Obviously not the same values. And I'm going to go with yes, I want to see more information. And I'll just go ahead and choose energy. And once again, you see the same line for Ohio instead, up until 2017. And I'm gonna just go ahead and click no, I don't want to run that trial since I did more than one. And here you see that it's separated by state, so each state has their own information in one area and the other one has theirs separated right after. And then the table created is separated by state, year, person per energy, the value of the industry they chose, and then the industry. And as you can see, the minimum was 1.612, which came from Iowa, which is correct, it's less than 270, and the maximum is obviously 2070. And then the total carbon emissions from all the trials, so it goes ahead and adds up that 4th column, and it's 271, which is right. And there's also some obvious limitations to our code. For one, it stops at 2011, so if you wanted to see any more carbon emissions past that, it's not going to let you. Our projection line is only good up until 2017 because that's where we plotted our point, because that's the year we're in right now, so we wanted to show you somewhat of where we're at now. And also, that line is only based off the previous points, so 2009, 2010, 2011, because those are the last 3 in our data range. So it's not based on anything else like technological advancements that might increase or decrease the amount of energy usage we might see in the future from different states. But a good thing about this code is that we're only showing you the carbon emissions from states within the United States, and we're already talking about metric tons of carbon dioxide in the atmosphere, and we're not even giving you the rest of the world. So this really should open your eyes even more and make you want to solve this further. So that's going to be our code. Thank you for listening, and I hope you have a great day.